Hello viewers, you're welcome back to Success Arena Academy. In my previous series of this video, I explained to you all about how to identify chemical substance on Waec based on solubility and based on litmus paper. Today, I'm going to be showing you the major aspects of identifying chemical substance, which is based on the use of chemical reagents. If you are new to my channel, please don't forget to subscribe. Just hit on the subscribe button to subscribe to my channel and hit on the like button to like my video. And also don't forget to share the video with your friends and family. Thanks. This is going to be the third series of this episode, and the last series, which is going to be the fourth series. I will be giving you the exact question, let's say likely question, that will be given to you in Waec based on the specimen that is given to us in my school in Waec. All together. So based on the specimen, we fish out the question that it is likely to be set by them, and the student can easily understand what is going to be happening. But you need to understand the basic here, because all what they said to you, you can easily get the answer from this place right here. Thank you. Now, I will talk about identification of chemical substances based on chemical reagents. Normally, many substances can be identified by treating the solution of their salts, aqueous solution of their salts, with chemical reagents that can either produce a gas altogether, or it can change a color, it can produce odor altogether. So any of these things that it can produce, either a gas or change in color, odor, or it can even produce a precipitate. You understand? Then we can use this thing to identify the kind of ion that is found in that substance altogether. Now, this thing is usually done in three ways. That means we normally use chemical reagents to identify three things in a substance, which is the major thing that is acting for you in Waec. Now, the first thing that we can use this chemical reagent to identify, we can use to identify cations in a salts altogether. As we also know that cations are positive ions altogether, and we can also use that to identify anions, which are negative ions. Now, with the exception of these two, we can also use this thing to test for food, and we can also use it to test for functional group of organic compounds. And we can use these same chemical reagents to test for the moisture that is found in a substance. When we said moisture, I'm referring to water that is found in a substance. Now, how would I go about this? And today, I'm going to be showing you how to identify chemical reagents. How to identify cations. Now, you see, you can identify cations in three ways altogether. The first thing, which is always what I always give to you to identify cation, not something in Waec. Whenever they are given that add sodium hydroxide altogether solution, or add aqueous ammonia solution, or add potassium chloride solution to an aqueous solution. If you have to add any of these three, sodium hydroxide, aqueous ammonia, NH3, or you are asked to add potassium chloride to an aqueous solution altogether, note that they want you to determine cations. Are you getting something now? Now, we have some major cations that can be determined by these three solutions. In chemistry, there are some major cations that will normally in experimental chemistry, there are some major cations that will normally determine. The first of the cations are listed above. You can either use it to determine ammonium ion. We can use it to determine lead-2 ion. We can use that to determine aluminum-3 ion. We can use that same to determine copper-2 ion, iron-2 ion. We can use to determine calcium ion. we can use to determine iron 3 ion altogether. Now, all these things can be determined. We can also use to determine zinc ion, and we can use that to determine, okay, potassium ion can also be determined, and then sodium ion can be determined. But I want you to understand something. These are the major cations that we have that we can determine, that you can get. Any of these things would be your inference altogether. But how do we go about getting each of these cations? That's what I'm going to be explaining to you in this video. Now, the first thing that you should understand is that whenever you are asked to add sodium hydroxide solution to an aqueous solution of the source of any of this, altogether, source of any of this, you are asked to add sodium hydroxide solution to an aqueous solution. Note that sodium hydroxide can only be used to detect all this substance that is here, including this and zinc. But sodium hydroxide cannot be used to detect potassium and sodium ion. Altogether, know that you can detect potassium and sodium ion when sodium hydroxide is added to this. Remove these two away from you, you can't detect them. Although we can detect these two majorly, potassium ion and sodium ion can easily be detected by using flame tests. That means their color, the color that they give to flame. We can use them to determine this potassium and potassium and sodium. But in using chemical reagents altogether, you can't use chemical reagent like that to determine potassium and sodium. Just note that. Now, how do we go about determining them? As we said that what we can only determine from here to this place using any of these chemical reagents. I'm going to be giving you one by one. Altogether. Now let's take a look at this. These are what you are expected to put down in Waec and how you are expected to put that down. Normally they are going to give you a test, which is they will give you that, okay, test, add C, they just say add C, add sodium hydroxide to solution of this, to the solution. Altogether, they will have given you this solution initially. Now, when I give you this solution will be an aqueous solution of any of these, compound, any of these cations here. Altogether, now you'll be given this. You might be asked to add either sodium hydroxide or add ammonia solution or add potassium chloride. Whenever they are asking you to add any of this, they know what they want you to determine. Okay, let me chip in something. This year's Waec, they are asking them to add sodium hydroxide. Please note, your answer to this year's Waec question will lie within iron 2, copper, ammonia, and then potassium and zinc. Altogether, why? Because we have to add sodium hydroxide in drop and in excess. That's why I think that's what they gave to us here. They gave us what? You have to use sodium hydroxide. And since they asked us to use sodium hydroxide, we know that what? We want that sodium hydroxide to determine these cations. Are you getting something now? Now, anions, there's a way of determining anions separately. You don't need to perform these experiments. I'm trying to tell you this, that what? You don't need to perform them. Just understand the basic of it, that you can easily say, okay, if I add this, automatically, this is what it's going to give to me. Altogether. Now, number 2, let's come again. Now, if I add sodium hydroxide solution on aqueous solution of the salts, this is the observation that I'm going to see, that you are referred to write down. The first one is that whenever you are seeing white PPT soluble in SS, look up. You'll be asked to add the sodium hydroxide in drop and in SS. Altogether. Now, if you add sodium hydroxide to a solution of any of these salts in SS, altogether, and it is not soluble. If it is soluble, if the solution is soluble, it forms a precipitate. Are you getting something now? Now, when you add sodium hydroxide solution to any of the salts, aqueous salts, it forms when it forms a white PPT. It forms a white PPT. That is precipitate, white PPT, which is soluble in SS. If that precipitate that is formed is soluble, then zinc, lead, or aluminium is present. Zinc, lead, or aluminium is what? Present. Now, I'm going to be showing you something here. Normally, you can easily identify any of these three here. You know, I said the three of them is present. Why? Because the three of them will be soluble. You got the three of them, these three salts here is going to be soluble. That is the reason why what they are present inside them. That is why they are soluble. Are you getting something out? Now, the next thing that we're going to be seeing is that if when you add it, you are getting a white PPT which is insoluble in SS. There is only one salt, one cation that will be insoluble, which is cation. Although there are some other ones that are what? Insoluble. But cation is insoluble. You can easily detect them by their property. You know, I said it forms a white PPT. Cation will surely give you a white PPT. All this one, zinc, lead, and aluminum, they will also give you what? A white PPT. But I can easily distinguish between them by is it soluble or insoluble. If it is soluble, then zinc, lead, and aluminum might be present in the solution. But if it is insoluble, there is presence of calcium ion in that solution. That should be your number 2 inference. The third one is whenever you are getting after you dissolve, when you pour that sodium hydroxide inside the aqueous solution of the salts, and you are not getting a greenish, so maybe the color changes into green. Altogether, when the color changes into green, it will look somehow dirty green. Now, and it forms a precipitate. Look at when you pour. Let me give you one thing. I think that's what they give us this year. When you pour the solution into when you pour the sodium hydroxide into the solution and you saw a greenish color, altogether it is green color that is produced, and that green color is insoluble. If it is insoluble in SS, altogether, now it shows that there is a presence of iron. Iron 2 ion is always greenish in color. Iron 2 ion is greenish in color. But to confirm that this iron 2 ion is truly there, then we can easily confirm it. How do we confirm it? When you leave it, because in the experiment they will say what? Leave it, expose it to air. When you expose it to air, the color of the solution changes automatically to brown. You know, initially when you pour the sodium hydroxide, it is green. When you now expose it to air, it's turned to brown. What has happened? Oxidation has occurred. Altogether, oxidation, iron 2 ion will automatically oxidize itself. When you expose it to air, iron 2 ion will automatically oxidize to form iron 3 plus. Why? It only formed this iron 3 plus by, let me say, I have what? E minus. Altogether, it's going to form iron 3 plus. Are you getting what I'm meaning? When iron 2 ion oxidize, it loses electron. Because if you look at what? Oxidation and reduction in chemistry. Oxidation simply means the loss of electron, while reduction is simply the gain of electron. Now, when iron 2 ion is being exposed to air, it tends to lose electron. When it loses electron, it becomes iron 3. Altogether, so when it loses electron, it's turned immediately to iron 3. Altogether. Now, the color of iron 3 ion is that brownish solution they are saying. So, in that case, you can easily say that what? Since it's formed insoluble in SS and the precipitate turned reddish brown on exposure to air, it shows the presence of iron 2 because it is iron 2 that will turn to iron 3 when it's exposed to air. Altogether, just put down that iron 2 is present. But if you pour sodium hydroxide in that solution, and what you are getting is now reddish brown PPT, which is insoluble in SS. Altogether, please, the major thing is always SS. So if it is insoluble in SS and the color is reddish brown, it shows the presence of iron 3 ion. Iron 3 ion is always reddish brown. The next one is now what? If you now pour it, you can easily identify copper with its color. Copper is blue. Copper is always what? Blue. Altogether, that is copper. Now, when you pour the solution inside there and you are seeing blue PPT, don't forget, copper is also insoluble. So, blue PPT, which is insoluble in SS, it shows the presence of copper 2 ion. Because of its own color, it shows the presence of what? Copper 2 ion. That is one. That's another thing. And that's the one that you can easily detect. Don't forget I said this thing you can use it to detect by their color changes, and you can also detect the cations maybe when they produce a gas. Now, take a look at this. Sometimes you might pour sodium hydroxide in that solution that you not see any PPT, that means precipitate. Now, maybe on when you pour this in there is no precipitate. But when you eat the substance, they might ask you to eat it. When you eat the substance, it's going to produce a gas. If the gas that is being produced, majorly the gas that you can get here, when you eat it, when you're asked to eat the substance, so first you know my brother is there. If you're asked to eat it, the major gas that you can get is only ammonia. Are you getting something now? Now, one of the characteristics of the gas, I think when I was explaining litmus paper for you, I explained one of the characteristics. You see, on eating, there is evolution of colorless shocking gas. Are you getting it? Ammonia gas is always colorless, and it is shocking. It smells like urine. Are you getting something now? So when you inhale it, it smells like urine. So it shows that, and one thing about the gas is that ammonia gas, as well to know that it is the only alkaline gas. Why is it that ammonia gas is the only alkaline gas that we have in chemistry? It is because ammonia gas is soluble in water. Are you getting now? It's going to be soluble in water. That's why it is the only alkaline gas that we have. Now, and one of the major properties of alkaline is that all alkaline turn red litmus paper into blue. Altogether, I think I explained during litmus paper and especially using litmus paper. So, if we dip litmus paper into it, they might ask you to test with a litmus paper. If you dip a litmus paper into it, it converts that red litmus paper automatically into blue, which shows the presence of ammonia. Altogether. Now, look up. The presence of ammonia gas is shown by the smell. While the presence of ammonium ion, if ammonium ion is present there, that is that conversion litmus paper test that you've done. The litmus paper test that you've done is only to indicate the presence of ammonium ion, NH4+. Then you're going to put there, since that you have to experiment, you're going to put that ammonia gas is liberated due to the smell. Ammonium ion is present due to the change in color of the litmus paper. Altogether, that's for aqueous solution. Now, what about ammonia solution? Before I move on to ammonia solution can be used to distinguish. Altogether, can be used to distinguish between zinc, lead, and aluminium. We can use ammonia solution to distinguish between both of the three of them. You know, when I'm using sodium hydroxide solution, the three of them produce white PPT. Are you getting, which is soluble in SS. The three of them will produce white PPT, and they are all soluble when you put them in SS. I also get when the solution is put in SS, the three of them will be soluble. But I can easily distinguish the three away from that solution by adding ammonia solution. So if you are given to add ammonia solution, altogether, note that you can test for, using ammonia solution, you can test for zinc, lead, aluminium, iron 3, and copper only. If you have to use ammonia solution, you can test for these cations only. Now, if you put ammonia solution there, when white PPT, which is soluble in SS, is produced, that is zinc. Altogether, note that, you know I said ammonia can be used to distinguish the three of them. Now, if ammonia is poured in the solution, only zinc will be soluble, while lead and aluminium will be insoluble. Are you getting what I'm saying? So, white PPT, if white PPT is formed, and that PPT is not soluble in SS, it shows the presence of zinc 2 ion. And if that white PPT is insoluble in SS, that is the presence of lead and aluminium. The next one is now iron. Don't forget that iron 2 ion is always green. Greenish color, right? What it has. So when you pour the solution of ammonia solution and it is giving you green PPT, it should surely be insoluble in SS. It is always insoluble. They might be soluble in drop, but when you pour them in SS, they are always insoluble. Now, when you see greenish PPT, it is always insoluble in SS. That shows the presence of iron 2 ion. Why? If you are having a reddish brown PPT, which is also insoluble in SS, it showcases the presence of iron 3 ion. Altogether. Now, the last one is now, whenever you have a pale blue, don't forget I said blue is used to indicate copper. So when you have a pale blue PPT, which is soluble in SS, to form a deep blue solution, because this one is going to change its own color. When you add this sodium hydroxide to that solution in SS, more sodium hydroxide, it will change from this pale blue into a deep blue. That is showing the presence of copper 2 ion. When it is changed from when the color is more denser, it shows the presence of what? Copper 2 ion. Don't forget that copper 2 ion will be insoluble in sodium hydroxide. Are you getting something now? But when it gets to ammonium solution, it becomes soluble. That's just note that. Now, in see the third solution, the third solution that we can use to determine cations is now the action of KCl, potassium chloride, on the aqueous solution of. Look up, potassium chloride can only be used to detect lead and aluminium. Lead and aluminium can be detected by what? Potassium chloride. So, if in your exam, whenever they say you should provide potassium chloride, note that they want what the cation that you want to determine here is what? Lead and aluminium. All together. In the first stage, if you add potassium chloride, you should assure that what? One of your solutions, one of these things, either lead or it is aluminium. Now, how do you now determine if it is lead that is produced or aluminium that is what? Produced? If when you pour the solution, when you pour this thing, your observation that you are seeing, you have what? There is no precipitate that is formed at all. If there is no single precipitate that is formed, when you say there is no precipitate, it simply means when you just pour it, you pour the solution into it. It look maybe I pour it into water, and that water will remain the same color. The color of that water does not change. That means maybe there is some particles inside it. It shows that no precipitate is formed. It does not form a precipitate. If precipitate is formed and it dissolves, you will see precipitate initially, then it will turn towards the same normal color of water. But if it is just ordinary water and it's colorless like that, it shows that there is no precipitate. So if there is no precipitate that is formed, it indicates the presence of aluminium 3 ion. Are you getting me? Why lead 3 ion can be what? Showcased by its formation of white PPT, which is soluble when hot. And it forms a white precipitate. And that white precipitate is always soluble when it is hot. And if you now allow the solution to cool altogether, it reappear. Are you getting something now? The soluble, the white PPT, you know it is soluble when it is hot. Then, if you allow it to cool down, it will now reappear back. It showcases the presence of lead 2 ion. Altogether, this means lead 2 ion is present. Now, all these things are quite easy for you to determine altogether when you get to the examination hall. Because that is one of the major problems that we have as a student is practical. If you can pass your practical, then I assure you that there is probability of you getting, not even probability, there is certainty they are going to score B in your Waec, which is sure, or in any examination. So in any examination, they can't go more than in qualitative analysis. Is either you have to determine the cations or you have to determine the anions. In my next video, I'm going to be showing you how to determine anion. And for you that you've not watched my initial video on how to determine gases using litmus paper, I'm going to be dropping a link in the description box below that will take you to the video so that you can watch that also and get more knowledge. Thank you for watching today's video. Please don't forget to subscribe to my channel. And also, please drop a comment for me in the comment box section below so that it just help me during YouTube algorithm, and also it will show that you really appreciate what I'm really doing to you. And don't forget to like the video. Click on the like button to like the video and subscribe. Thank you so much.